Hey guys, how's it going? Welcome to another RMA Fire tutorial. This is RMA, I'm Alejandro, and this is what we're going to be creating today. So, we are going to be building this effect where we have some really cool dissolving action on our character. It can really be anything. This can be any character you want it to be. In this case, we're using a sculpture, and the effect has a couple of different layers of complexity. I'm just gonna sketch them out on top of this so that we know exactly what it is that we're gonna be building. So we need, the first effect is gonna be the dissolving of the actual geo. Then we're gonna need inside particles. And then we're gonna need outside particles that have this sort of like leading edge. So outer particles. And that's it. We're gonna be mixing these three effects. They should give us something similar to this. And then we'll touch on briefly how to get this sort of like really cool, colorful lighting with beautiful reflective properties onto it. Right, so without further ado, let's go ahead and jump straight into Houdini and see how we can create this sort of effects. Alright guys, so we are in here inside Houdini. We have, as we spoke about earlier, three effects. The main part, where we're going to create the main thing, the broken geometry, and the inside points. So the main part is we're going to be rendering the outer particles. So this would be outer particles, broken geo, and inside points. Additionally to this, we have three lights, an HDRI dome, and two adjacent component lights. And I have two cameras in the scene. This is what you're gonna get when you open up the file. I'm gonna make everything invisible except for the parts that we need to work on primarily, which is gonna be our main. Let's come in here onto our main, and let's have a look at what we're gonna be building. So at the beginning of our network, you will see that I have a sculpture. Okay, I'm gonna share with you guys this sculpture model, but I will share with you also where you can get this kind of models. So if we go to mini scans, to scan the world, super cool, helpful website for you guys to check out. You come here and you go to full collection, and you're gonna see that there's a huge library of scanned assets that you can pick from. So I just went through here and I picked one that I thought was a sculpture that I wanted to destroy, that I thought was cool. But you guys can literally choose whatever sculpture you want for this. Alright, so this is a very cool and helpful website, and we'll put this on the tutorial description. So the first thing I'm doing is I'm reversing the normals, because if we bring this in, scale it down to 0.01, because we want to work on real world scale. If you bring in models, you want to measure them to see what size they are. So I usually bring in a box, and I know a box is 1 meter by 1 meter approximately. So see, that's kind of the size that I wanted this geometry to be. And then if we apply this reverse, it pushes the normals, flips the normals, so that now the normals are facing the right direction. We're scaling it, and then I'm using a clip. And what the clip does, it just clips part of the geometry. So if we use a clip right here, and you hit enter, you can see that you can control what part of the geometry you want to keep. So if we look at it here, see, it takes a second, but you see how it's gonna clip and just get rid of everything else. Just because we don't want to worry about her torso as much as the face, which is our main focus here. After that, I am doing a polyfill, and what this polyfill is doing is that it is filling up the bottom part so that it is not hollow like this. So we want to fill out that area. So we got our base, and we are creating two things here. So base, we put it on all to output it, and we want to have the scatter points. And what the scatter points are doing is that it's literally just scattering points, but it's not filling up the inside. And the points from volume will fill up the inside. And what I'll do, just for the sake of the tutorial, I am gonna reduce the amount of points that I'm scattering inside, just because this is the high res version. So I'm just gonna do 5 tutorial, and I'll post both versions, the final one and the tutorial one. And then I'm gonna just reduce the amount of points that I'm scattering, so it's less, so you guys can see real time what's happening. So that is that, and then we'll do the same thing here. Just do much less points that are being scattered outside. So this is kind of like our crust, our surface outside, and this is our inside. And the inside, I am basically doing a 0.99 the size, but I am centering that. What that is if we use a transform, and on the transform we come here to the pivot, and we are going to give the pivot an expression of x, y, and z. This centers it on the center of the geometry. So when we scale it down to 0.9, it's going to scale it but on the center. So I'm just making it slightly smaller so that we have a little bit of space in between the surface outside and the inside points. Almost like leaving a little bit of a gap. I'm just gonna sketch it out so it makes sense. So it's kind of like this is kind of like our model inside, like horrible drawing, but this is sort of like filled up with points, which is this part. And then the scaling down is leaving a little bit of a gap here between the crust, so that the crust is just like a thin layer of points outside, which is this one. And then we have this little gap in here without anything. What's happening here is I am grouping I'm putting a couple groups. So this is $OS, so that the group is called A, and group B is the other part, and the group is being created using a keep bounds region. So it's basically just like a group, and the group is being turned into points, and then we're using a keeping bound, and then the bound I'm just making way smaller. So it's just like a little small block of selected points. And what these points are gonna do is that they are gonna dictate where the temperature attribute is gonna go from. So if you look at it here, this is an attribute create, and is creating an attribute on the points A and B, group A and group B. So we tell attribute create this temperature attribute on A and B, and we're giving it a value of 1. So that means that wherever these points are, that's where we have a temperature attribute created. And then we're using a Pyro spread, and what the Pyro spread is gonna do is it basically grabs those points, and that's where the temperature grows from. So if we were to visualize this, I'll show you guys in a second. Okay, guys, so like I said, we have group A, group B, both activating a temperature attribute, and then the pyro spread. We put the pyro spread here, and then we tell the pyro spread that we want to drive temperature. So it's gonna find, you see how it colored them? Find those temperature places, and then it's gonna spread a noise from them. And right now it's very small, but that's because we have to tweak it here. So I found a value of 0.01 and 8 on the neighbors. I'm just making this noise. Like you come here and you change the noise here, and you change the size of the noise. These were the parameters that I found. This is gonna change based on like the size of your of the geometry that you're infecting. But as you can see, this is gonna grow from the place where we put the groups, this sort of temperature spread. See? And that's dictating where we want the geometry to disappear and the particles to grow from. The same thing is happening on the inside particles. As you can see, I am using the same area of where it starts, literally, and the same place here as well. So what's going to happen is that it's going to spread on the inside at the same rate that it spreads on the outside crust. And here we have the exact same thing. The spread is growing. But in this case, you can see that it grows on the inside as well, just because we have points in the inside. So what the pyro spread is doing is searching for neighbor points. So you can play, oh, I wanted to search for more points. I wanted to cool faster or cool slower, you know. So this is gonna change the result that you get. Following this, I cached it. And then when you cache it, you'll see that it's gonna load much faster. But mine has obviously, it's cached with way more points. At kind of like the rate that I found that it was gonna give me what I wanted. And then what I'm gonna do is color this and then tell it that my infect is equal to temperature if it's less than 0.01. And then this is creating a group. So basically, I, meaning an integer called infect, is equal to any temperature that is less than 0.1 in value, right? So this part is less than 0.1 in value. That's why we're here. So we were saying add temperature is less than 0.1 in value. So it's putting them on a group. Okay? So we have an attribute that is called infect. We have a group that is putting the same thing that is equal to that infect 0.1 into that group. And then I don't know why I put it 2 times, but I don't need this one. And then this is, sorry guys, let me just double check something. Yeah, this is the same thing that I put here, so it doesn't matter. So our infect is kind of like the group that is called infect. It's both a group and an attribute called infect that is growing in this area. And then inside of our popnet, we're gonna first create in the pop source all points. Birth equal to 1, so that we want points to grow to exist only on the first frame. And just for the sake of the tutorial, I'm just gonna add a delete right here. And I'm gonna delete points by range. I'm gonna delete 5 out of 6 points, just so that we don't have as many points as I have in the final result. So basically that means that we're only gonna emit points on the first frame. That way the particles aren't emitting points every single frame. We are using her velocity, but set to 0. And that's it for that. Then the subsolver. What the subsolver is doing is that it calculates what happened on the last frame, every single frame on the simulation. So it is reading the infect that we created earlier. So basically it's, oh, in this frame, the infection group. So it knows every single frame that the infection is growing. So it's grabbing this group, or not necessarily the group, but like the attribute that we created. It knows that, oh, okay, in this part it is this big, this big, this big. So that it emits particles, or that we can control what happens with those particles that are activated. So then we're doing a pop force, and we're saying, if the infect is less than 0, then please add a little bit of noise. Let me turn this off so that you guys see what I'm talking about. So if we play, you're gonna see, oh, the infect is less than 0. Oh, okay. So I'm gonna, if it's less than 0, then it's not infected. But if it's more than 0, then it means that it has been infected, and I'm gonna add some noise to it. So it's gonna start to add some noise to that area. See, so it starts to like give those particles a little bit of action. As they get infected, they get activated and they receive pop force. And you can increase this so that we can see the value of the particles being infected much larger. Cool. You can see it happening there. But then like what I did is, if you want to control, oh, this is moving too fast, or whatever, you can add some drag so that it feels like more sleepy, more slow. And then this color is affecting group 1, which group 1 we created it here. So this is group 1. So if the temperature, is less than what we had dictated, then it's, or more than, it's gonna change the color. You can control that based on that greater than or less than value. You pick whatever color you want here. It's just for visualization. I'll show you guys a trick. Like basically, we can do the same thing here with the group or with the attributes. So if we do a color, and we come up here and we're like, okay, the infection is less than 0.1. We're gonna visualize that using the attribute, and we're gonna say infect, and you see that it will color the attribute, and then that way you know how much of it you're actually affecting. And then here you can do the same thing for the temperature. And I'll show you. The temperature is essentially the same thing as the infect. So, like I said, we are telling the solver that every frame, whatever infection has grown, please activate it. add a little bit of noise to it, add a little bit of drag if you want it to be more sleepy, and color them so that we can visualize them easier. That's it. That's all we do here. And then the same exact thing is happening here for the inside particles. Nothing really changes. It's the exact same thing. Obviously, it's gonna be super slow because I really did pack it with a lot of particles so that it had all that detail, and I left it cooking overnight. So that's it. I'm not even gonna load it because it's gonna take a long time to load. I'm gonna load the low res version that we did here. Maybe we can increase the resolution just a tiny bit, just for the sake of just like seeing what's up. And we can hit play here. But the problem is my values aren't really gonna work as great because the values that I set here were set to that resolution. So, like I said, the values are relatively dependent on the resolution that you add to this. Let's see, color ray. Increase the infection. Now let's see, roll rate. Let's make it 2. And let's visualize color. So in this color, I'm doing the same trick. I'm just writing the temperature here so that we can see what's actually happening. You can see that it is spreading. And in this one, it infects the points inside because it's a filled volume, right? So after that, I am caching it to disk. And here's what's happening at render time. So there's a couple tricks that I'm doing on render time. On the scattered surface, you can see that it's entirely filled up. We're not gonna use my cached one, we're gonna use the one that, the low res version here that we were doing for the sake of the tutorial. Alright guys, thank you very much, and I look forward to showing you guys more cool stuff.